Now, if you are new to AI, you must still be stuck with AI just being ChatGPT. Some fun images and videos, and that's about it. Every other week, you might hear some people talk about a new announcement, Claude Code, Gemini, but to you, you're confused. What has changed? How has it changed? Fret not, today I will bring you through same and effective applications you can use for your daily use. We will first build a website if you own a business, and a calorie tracker app for your own personal use. And the craziest part, all easy and free under an hour. And you know the craziest part, I will show you how to run this on a MacBook 2014 Retina Pro, a 12-year-old MacBook. It's that crazy. You don't need expensive hardware to run all this. Let's dive in. Let's begin by installing Anti-Gravity. Just head over to the Anti-Gravity site, download the runtime, and pull it over like any other Mac app or Windows if that's what you're using. Now you can find the icon and run it. Over the past few months, Google Gemini Code Assist, what many people casually referred to as anti-gravity, became one of the most widely used AI coding agents. Its popularity came from two things: powerful agent-style workflows and unusually generous usage limits. At first, it felt almost unrestricted, then those limits expanded even further, and recently they tightened again. Meanwhile, Anthropic had already been building something arguably more powerful, Claude Code. For a long time, it consistently ranked at the top for real-world development tasks, but it was locked behind paid plans. That's what made it inaccessible to most people. Now that's changed. Claude Code has effectively opened up, and when you combine it with the right tools, it becomes something much bigger than just a coding assistant. After using it heavily over the past few weeks, one thing becomes clear. It doesn't just help you code, it can replicate the workflow of an entire team. So let's head over to the Claude website. Once you're there, copy the relevant commands or code snippets provided on the page. After that, open your terminal and paste them in. At this point, everything you see in the folder, especially in your downloads directory, is essentially all the files that were just pulled in or generated during the process. It might look messy, but that's expected. You can click through all the settings, but it doesn't matter much now yet. If you see this, you're done. It's that easy and you have not spent a single penny. You guys are safe with me, don't worry. Now that we have installed Anti-Gravity and installed Claude, let's pull out our kitty map if you're lost. Always come back to the kitty map. Now we will try unlocking the system. First, we will open up Anti-Gravity, then we will do the following to start running Claude code inside Anti-Gravity. If you are on the latest systems, you can actually skip a lot of the steps here, and if you are willing to pay, you can again skip many of these steps. But this is not why you are not here, aren't with Anti-Gravity or any other development software. Or you could also perform the same steps directly from here. We'll essentially have the same terminal. So if I enter the same command, launch Claude, and press enter, the same options will appear, and I'll be able to use it in the same way, but with the added benefit of previewing the files in the project. So you follow, to fully unlock Claude code, we pair it with Ollama and OpenRouter, which opens up even more possibilities. Founded in 2023, Ollama has quickly become one of the leading open-source platforms for running large language models locally or on your own infrastructure. Its core philosophy is simple: give developers full control over AI models instead of relying entirely on cloud providers. Inside Ollama, you'll find a growing library of open models, local and remote execution options, thousands of integrations and tools, the ability to run advanced agents like Claude Code in a more flexible way. Installing it is straightforward, either through a one-line terminal command or via its desktop app for macOS, Linux, or Windows. Once installed, you can configure and launch Claude Code directly from your terminal. From there, you choose your model. You're not limited to one ecosystem anymore. You can use cloud models like GLM5, open models like Qwen 3.5, or lightweight local models depending on your hardware. And importantly, you control how much access the agent has, full system access or just a specific folder. That alone changes how safely and precisely you can work. Use case 1, creating your own AI agents instead of prompting repeatedly. You can now define reusable agents, like hiring a specialist that never forgets instructions. Inside Claude Code, you can generate an agent simply by describing its role. For example, analyze CSV or Excel data and convert it into a visual dashboard with charts and insights. The system builds structured instructions, tool permissions, memory configuration, behavior rules. Once created, that agent becomes reusable across your workflow. When tested with a real dataset like a multi-sheet real estate file, you don't just get summaries. You get interactive dashboards, filterable visualizations, automatically generated insights, exportable web interfaces. This isn't just data analysis anymore. It's turning raw data into applications. Use case 2, AI plus visual generation. Now combine this with generative media tools like Runway ML or Pika Labs, Instead of static assets, you can generate layered product visuals, animate them into sequences, integrate them directly into a website, for example. Taking a product image and transforming it into an animated composition where elements assemble dynamically, then embedding that into a scrolling web experience. With Claude Code, you don't just design the page, you describe the experience and it builds. Layout, animations, interactivity, media integration. The result feels closer to a modern product showcase than a typical web page. Use case 3, building full applications with skills. Claude Code also supports extensibility through skills and plugins. By importing external repositories, you can instantly give your agent new capabilities. File system analysis, PDF processing, UI generation, testing, frameworks, automation pipelines. This turns a single agent into something closer to a modular development team. For example, you can build a local application similar to disk cleaning tools. Scan directories, detect large or duplicate files, sort by size or age, provide a UI to manage deletions, all generated from a single prompt. This replaces the need for many standalone tools and, more importantly, lets you customize everything. Use case 4, removing limits with local models. Cloud models are powerful, but they come with rate limits. That's where local models come in. Using Ollama, you can install models like Qwen 3.5. These run directly on your machine. The trade-off, slightly slower depending on hardware, but completely unlimited. You choose based on your setup. Lightweight models, 1 to 2 gigabytes for basic tasks, larger models, tens of GBs for advanced reasoning. Once installed, they integrate seamlessly into your workflow. No API limits, no usage caps, just local execution. The bigger shift, what makes this moment different, isn't just better models, it's control. Before, you used tools, you adapted to their limits. Now you build your own tools, you define the limits. We're moving from AI as a feature to AI as infrastructure. And once you understand how to combine systems like Claude Code with Ollama and open models, you're no longer waiting for new tools to appear, you're creating them yourself. So now we're going to try installing the Claude Code. First, head over to the website I showed earlier. Once you're there, copy the relevant commands or code snippets provided on the page. After that, open your terminal and paste them in. At this point, everything you see in the folder, especially in your downloads directory, is essentially all the files that were just pulled in or generated during the process. It might look messy, but that's expected to get started. We'll use one of the cloud-based options first. So I'll paste the command back into the terminal, making sure I'm inside the downloads folder before running it. Also, I'll show you how you can open and manage this directly from your IDE if you prefer working in a graphical environment instead of the terminal. Another thing to note is that we can actually install a LLMA-based model using Claude Code, which unlocks more advanced features for free. What this gives us is access to a broader ecosystem of AI capabilities, similar to what you'd get from larger providers, but with more flexibility. If you notice that everything seems to be installing again on top of what's already there, don't worry, that can happen. The process usually only takes a few minutes anyway. Next, go to the Docker website and download Docker, install it just like any other application on your system. On Mac, for example, it's as simple as dragging the app into your Applications folder, similar to using a magnet to snap it into place. If you've already installed Docker, then you can skip this step. Once it's installed, you should be able to open it and have it running in the background. After that, we move on to installing Ollama. Once Docker is set up, go back to your terminal and paste in the required command. When you run it, you should see the installation process start. This step can take a bit of time, so feel free to grab a coffee and come back while it finishes installing. Once everything is ready, you can run the model, and just like that, you'll have your very first local AI model running on your own computer, even if it's an older PC. Let's test it with a simple question like, what is the capital of Japan? You'll see that it responds. And while it might not be as fast or polished as cloud-based systems, it's still impressive. The interesting part is that everything is running locally. Nothing is being sent to the cloud. This is entirely on your own machine. So even if your internet connection goes down, you can still use it. Let's try another example, maybe something in Chinese. You can input a question in Chinese and see how the model responds. The answers might not always be perfect, especially with smaller models, but it's still fascinating to see what it produces. Sometimes the responses may seem a bit off or unclear. That's often because the questions weren't framed properly, or because we're using a smaller, less capable model. With better prompting or a larger model, the results would improve. All right, once everything is done, that's essentially the setup process. From here on, whenever you want to use it again, just open your terminal, make sure Docker is running, and execute the same command to start the model. Hit the run or play button if needed, and you'll be back in the interface. You'll know it's working when you see the prompt again and can type something like, "Hi, how are you?" and get a response. It's lightweight and suitable for older machines like a MacBook from around 2014. It will pull the model from the source, and once it's ready, you can start interacting with it. Before moving on, note that when you start using these models more often, things may feel a bit slow at first compared to what you see on ChatGPT. But as you can see, it's not deadly, it's fine. When the model runs, you'll execute the same command again and you'll see it respond. You can start asking it questions. For example, you can ask simple prompts and observe how it generates answers. You'll notice that smaller models take some time, but the performance is still quite decent unless you need something very powerful, which more often than not you don't need. One key advantage is that you don't need the internet. These models can run entirely offline. As you can see, the responses are fairly decent. In a nutshell, you've now seen how to run a local model on an older MacBook. It's a great way to experiment and satisfy your curiosity, especially if you're working with limited hardware. Next, we'll show how to install additional tools. Before that, you'll need to install Node.js. It's straightforward, just copy the installation command and paste it into your terminal, then let it run. Once that's done, we move to OpenRouter. OpenRouter is a platform that gives you access to many different models. Go to the website and sign in. Then navigate to the API key section, click Get API Key, go to Setup, and create a key. You can name it anything you like. This key is yours, so keep it secure. After that, return to your project. Open the configuration file, JSON, and paste in the necessary code. But before we do that, you need to do a few things like creating the JSON file here by pressing Ctrl-Shift-, and then to unhide the hidden files, go to View and select the Unhide option. One important note, you'll need to add your API key into the file and also select your model, which we will show. On the OpenRouter page, you'll see a list of available models. For this walkthrough, we'll focus on free models. Select a free model, copy its name. This time I selected OWN 3.5 because I heard about it somewhere and got to try it. As an amateur, that's all about it trying it out free. Now paste it into your configuration file. Save the file again and you are more or less done. Now go back to your terminal and load the model. When prompted, confirm with yes. If everything works, you'll see it running. If not, try again or troubleshoot as needed. You can experiment with different models. Some may perform better than others. For example, if one model gives errors, this error looks like it's with the model being used by too many people. That's not something I can solve, but sometimes trying again works. So we will do that, and there, as you can see, it works. If you encounter errors, retry or switch models. That's part of the process. If needed, you can even ask another model like ChatGPT to help debug issues. Now we want to test real-world use cases. For instance, copy data from a website. This time it's FinViz. FinViz is a stock market website. Let's say you trade and you want the code to automatically make a presentation for you. Let's first ask the model to extract structured information like converting it into a CSV or text file. Some models will perform better with fewer errors, and you'll notice the differences as you test them. Most of these options are free, although there may be usage limits. If you hit those limits, you can explore alternatives. Now for me this time, it looks like this model has some issues. So let's move on. So I will try the NVIDIA one because it's free. So again, we fill up the configuration file with these details and we go back again to prompt it. Now, an important point. After installing everything, you might realize that the agent can handle much of the setup for you. Instead of manually troubleshooting, you can let the agent run tasks. Often, you just need to confirm prompts by clicking yes, and it will handle the rest. Eventually, you'll reach a working setup. From there, you can ask the agent to create something, for example, a simple presentation. It may go through multiple steps, consuming tokens and generating code. If you don't want certain actions, you can decline them. Now, as you can see, it generated a text file for me. If that's what you're looking for, it's good enough. But this time, I was expecting a PPT, so we will proceed with asking it more. So again, after a few yeses, you can see we have a PPT. If you don't have PowerPoint installed, you can open them in alternatives like Google Slides. So we have shown one real-world use case of making a PPT from some raw data. As you can see, I did not do anything, and basically it was generated by code in less than 5 minutes if you got the correct model. And the keyword? Free. Next, we'll explore another example. Let's say you're working on a social media project. You're a shop owner who owns a sushi shop. I love sushi, by the way, so you want to make a website for your sushi shop. First, generate images. For example, create a sushi platter image with a specific layout. Now I have covered quite a lot of these topics in my other videos, you can refer to them. But if you really need help, comment below. Once the image is ready, move on to video generation. Use a start frame and end frame, add them to your project folder, and let the system generate a video. I want the sushi meat to move to the rice and assemble themselves. With the video ready, return to your workflow. Upload the video into your project folder and provide instructions. The system will process it and generate a prototype. Again, it's a lot of yes clicking, and if you don't know what you want, just click yes. Remember, I'm showing you the free way. This first prototype may not be perfect, but it's a good starting point. You can see the sushi moving around already, and it's quite good. Might cost you quite a little if you do it outside. You can refine it by giving additional instructions, such as changing animations or including full video inputs. Each iteration improves the result. Now, as you can see, the second iteration makes the video stationary and clearer. There are other issues, but we won't cover that complexity today. Let's go back to the kitty map. At this stage, we've covered multiple tools and workflows, including IDE usage, cloud, different models, and building simple applications. And free. We've built examples without spending money using free models and tools. Now for the final step, go back to Ollama and open your terminal. Run the command to start a new project. Then select a model. This time you might choose a cloud-based option. It may prompt you to connect your Google account. Complete that step, then return to your project. Before continuing, configure your settings properly. Create a new project folder, for example, for a food recommendation app. Launch Cloud again and start building your application. But before you do that, note that you have to change your settings.json file earlier to this code snippet above. Now with that all done, go to Terminal again, launch Claude. And this time we will select the Llama 5 cloud model. Note this time I didn't really install anything, it's all in the cloud. Now to our task. I have had my sushi because the website was so good. I ate too much. Now I need an app to keep track of my eating. So I want a calorie app. So I will go to first start a new folder, for example. You can create a simple What Should I Eat app. It might suggest meals like cheeseburgers, fried rice, or tacos. And in Claude, I will go and ask it, can you make me a food choice and calorie app? As you can see, this is much faster than the last one as it's a newer model and it's in the cloud. And again, it's free. Now it's done in less than a minute. Wow. You can see the features like calorie tracking, random suggestions, and user interaction buttons. As you interact with the app, it updates your calorie count and provides feedback. I added the chicken rice and it updates. I click the add button and it adds. I click the random choice and it helps me choose. If you exceed a limit, it can display a warning pop-up. At this point, you've successfully built a working prototype. Let's go back to the kitty map again. So we've explored multiple models, including NVIDIA-based ones, cloud-based models, and local models. We have made 3 apps and they are all free. This demonstrates how you can combine tools like an IDE, Claude, Ollama, and OpenRouter to build applications efficiently. I hope you had a good time and see you all again soon.